Hi everyone, my name is Marco. I'm from 3D Survey team, and today I have a pretty interesting webinar for you with the topic how to use drone and phone camera images in one project. The webinar is being recorded, so at the end of the webinar you will get a link with the recording view, so you will be able to see the webinar again if something was not understandable. Once again, if there are any questions during the webinar, please feel free to set your questions in the question box so I can answer the questions during the webinar or at the end of the webinar. And if we go now with my webinar presentation, for a short introduction about myself. So I'm kind of a land surveyor, graduated at University of Ljubljana. This was more than 12 years ago, so I have more than 11 years of field experience. At the beginning, I was working with traditional technology like with total station instrument, GPS measurements, and did a lot of survey maps, topo maps, a lot of cadastral projects, volume calculation project, all that kind of things. And now more than 10 years already, I'm working with technology so-called close-range photogrammetry, where our drones and photogrammetry software directly connected with. So I have some experience. I finished already more than 1,000 projects based on this technology. First few years, those were projects for end customers. Now we are doing some tricky specific projects where we test this technology and try to make it easier for you to process it on a daily basis. I'm also a product manager at 3D Survey, so get some good feeling what's happening in this with the software and which way the software will go and so on. And of course, because I'm flying with drones, I'm also trained drone pilot operator. And if we go to webinar topic for today, we have a nice project. It's this kind of small vineyard house which is going to be renewed because it's an old one. They need to build almost a new one, but they would like to restore it, not to damage completely down the house. They would like to continue and renovate it like a restoration project. And that kind of projects, the first step of it is that they capture all the small details. Actually, for this project, they need actually a building footprint, they need roof dimensions, that they know how much material they will need to renew it, and of course, some specific points like the lowest and highest points. But we will see this later on, what's the main topic. Then the second thing I would like to explain you, it's equipment which was being used here. In a third point, we will see detailed instructions for data acquisition, how to get the best results out of it. And what's specific of this webinar, we will try to include also handshots from phone cameras. So instead using just the drone images, we will use also handshots in addition and try to get the best possible model out of it. And of course, last point, the basic workflow with results and so on. We will try to represent you most out of it. What's the main goal of this webinar? I would really like to show you how the most successfully combine phone images together with drone images, because sometimes it's pretty tricky because the camera it's different, so phone camera is different that drone camera, and you need to be really careful to get really the same perspective at the beginnings, that those two cameras can combine together and that all images are at the end successfully matched. But before we go right into it, I have two simple questions for you. So I would like to launch the first one to see what kind of audience we have. And the first question is, are you already 3D Survey customers? And your answer is, the first one is yes. The second one, no, I'm using another software. And the third option is no, I'm still designing for this technology. Okay. So the pool is in action. Let's wait a couple of more seconds. Lots of you already answer it, more than 70%. Okay, a few seconds. Okay, I will close the pool now. And the result of pool is 53% are already 3D survey customer, 80% are using another software, and about 30% are still not in this technology. Great to hear that you will see what's able to do with this technology and so on. Of course, I can share also those results with you, that you can officially see the result. And during this, I will also share another question, and this one is visible right now. Actually, the question is, did you already try to improving your model with phone images? So did you already try to do this, what we are going to see in this webinar? A simple two answers, yes and no. The pool is in action. Okay, 65% already voted. Let's wait a couple of more seconds. 70+%. I think this is already a realistic one. I will close the pool and share results with you. So 28% did already use this combination. So to combine also handshots or phone images, and 72% are not using this. So you will be able to see how to do this, what's the result of this, and so on. Okay, this was our quick pool. Let's go back to my presentation, and first one is a bit detailed description about the project. So this was kind of a small object, 9 per 5 meters, nothing special. I could measure this with a total station and so on, but instead of using this, I had the drone in my equipment. I need approximately 50 minutes to do the mapping, and I need to measure one ground control points for orientation. Later you will see this was a Phantom 4 RTK which was used here. And what was my requirements for this project? The main goal was to deliver the building footprint. So I need to vectorize at the end the building corners out of it. I need to deliver roof dimensions of this building, because they need to know how many materials they need to order it and replace it. And this is everything in 3D. So if you're using a standard method like measuring tape or something like that, it's kind of more difficult and not so convenient. That's why this is a great technology. And at the end, I also need to deliver them some characteristic points like lowest point, highest points, and so on, to calculate out also the slopes and everything like that. So these were the requirements. Then I use a mapping approach, which is not the standard one. Usually customers are flying simple grid and that's it. But in my case, I'd like to get as much detailed object as possible. So the best 3D model from images to get out all the information. That's why I did a manual flight on 40 meters with a nadir camera. So the gimbal was turned 90 degrees down. And when I finish with this automatic flight, I add a circle mission flights, which I need to fly actually manually, because in the DJI Airtica app, there is no option to fly circles. But I'm a kind of a trained pilot, and this was super easy for me. What's important here, you will see also later in the software, I did more circles, and if I start with the grid mission on 40 meters, I start my first circle on 35 meters, then I go 5 meter lowers on 30 meters, 25, 20, and so on. So I try to connect all the images together to get the greatest model out of it. And at the end, I was flying actually at 5 meters above the terrain, or even less, because my phone images were triggered from 1.5 or 2 meter height, and I'd like to connect those two data sets together. But you will see everything also later in a real presentation. GCP setup, because I had a RTK drone, I used just single drone control points, which helps me to improve the height of the model. Probably without GCP points, I would get, let's say, also in a centimeter too. Sometimes there's a displacement of 10 centimeters, but to eliminate this error, I just use single ground control points and everything was fine. Usually, if we have bigger terrain, we use 3 to 4 ground control points. Just to be on a safe side, this is surveyor approach. You always do some tests and so on. Okay, what kind of specifics do we have here? We need to deliver the building footprint of the basement, and from the first floor there were some corners which were under some kind of objects, so that's why I decided to include also images from handshots triggered with phone camera, and let's see what kind of results we get out. Okay, I go to my next slide. Equipment which was used here was my phone, Google Pixel 5. It has actually, I think, 12 megapixel camera or something like that, and Phantom 4 RTK. Instead of using my phone camera, even better option would be to use a standard digital camera, because it has a bigger sensor, the pixels are bigger on the sensor, and of course the end results is much better than. But if you don't have a hand camera, take your phone and that's it. What's good to know it, turn off the GPS before you start triggering handshots with camera, because this telemetry is not so good that the drone telemetry, and at the end it will destroy actually the accuracy, or not so many images will be matched in the bundle adjustment. So turn off the GPS, that you're not going to geotag images which were triggered with phone. Okay, I use the Leica GNSS device to measure single ground control points, and of course 3D survey software for processing. My instructions for data acquisition, really quickly, I already explained in a short how it goes. So the first, I did a drone mapping grid mission on 40 meters, then circles around the objects. I did altogether, I think, 4 circles. So in a way, 30 meters, 20 meters, 10 meters, 5 meters. What's important here, get your drone images pretty to similar perspectives than the phone images. I know that sometimes this is not able to do it because you have some trees or something like that, but you will find maybe one corner where you can connect 5 cameras from drone with 5 cameras from phone or digital camera, which are kind of close enough that the informations are pretty the same, that they are the same distance from the object, and this is definitely the safest way. Then later on you can continue with your phone and go even inside of the objects. I forgot to do this one, would be even more interesting, but maybe on some next webinar. Then phone images start from the similar perspective. I already explained this few times, but this is super important. In most cases, if user write us that they are not satisfied with the bundle adjustment step, that phone images were not included in the object of drone images, this is the reason. So they changed the scale between those 2 cameras too much. They didn't have the same perspective and so on. And keep in mind also, when you are triggering images with phone, you need to have good overlap between images. So every detail needs to be on at least 4 or 5 images. So minimum overlap is 70%. And if you go closer to some objects, go step by step. So if you are 10 meters away from the object, from the building, don't go then directly to 1 meter, go from 10 meters to 5 meters to 3 meters to 1 meter. So something like that. Okay, so this is about the quick theory, and now I would like to share you video which explain you everything about how it goes in the praxis. Okay, we are back from the field, and I just copy all the data from drone SD card and get 2 folders. The first one is survey folder, and the second one is 100 media folder. I also create a phone folder and copy inside my images from my phone. because I already mentioned here, we've been mapping here with the Phantom for RTK. The first thing was a standard grid mission, and images in a standard grid mission are usually written in a survey folder. If I open this folder and subfolder, we see those images from the air. So approximately, let's see, in my case, we have 86 images from 40-meter flying height. If we move between the images, you can see those are perpendicularly turned down images, so 90 degrees camera gimbal. Here is our object of area and nothing special. With those images, we really get a wide area and cover the complete site we would like to have. Let's go back then. The second folder from drone is 100 media. Here inside we have all images which were triggered manually. So I clicked trigger camera for every image. Those were actually kind of a circle flight around my object of interest, which is the building in the middle of image. And I'm just moving between the images that you have a good feeling how I trigger those images. What is super important if you like to successfully combine all images in your end model. And actually the first circle was on a height of 30 meters. I'd like to connect the automatic flight, which was a grid mission on 40 meters, and all manually triggered images which were flying around the object in a circle way and triggering. So the first circle was done on approximately 30 meters, and then I go down to 35, 30 meters, 25, 15, and so on. Let me go a bit quicker here, just to give you a good idea how I trigger all the images. As you can see, I really trigger a lot of images, but this just give me really safe data that in the end model will be really nice. Better have more images than less images. Nevertheless, you can always exclude images from your model if the model is too detailed and so on. But if there are some images missing, maybe not all cameras will be bundle adjusted in your model. These are still drone images. As you can see, I go really low. This is probably 7 or 8 meter height above the terrain. What's here super important is if you like to successfully combine also phone images with your drone images, you need to get pretty similar perspective from the starting point. Okay, that's why this part of object was the most tricky one, because I also like to get the corner from the building here and also in the first floor, and sometimes it's hard visible, especially the upper corner here, because I need to create for this project footprint of the building. I need to deliver roof areas and lowest and highest point for the building, as I already mentioned. This is still flying with the drone. As you can see, I go really low to get all the details, also trying to get the detail under the roof and so on. I already mentioned again, it's great to have pretty similar perspectives from the drone and with the phone images. And I finish here. The closest one image, which will be pretty similar to phone image, is probably this one, and this one. And this part is super important to include also the phone images which are from 1.5 meter height above the terrain, or 2 meter height or something like that. And let's close now the manual trigger images and go to phone folder and see. You can see, so when I trigger this image with phone, it's almost pretty the same as drone image. And this is kind of a good starting point, and then When these first 5 images are matched with the model of drone images, I can go and continue walking around the building, go even closer, I under the roof to get also a lot of details, go around the building, even when the first part is successfully connected, now those images will be also additionally connected and I can walk inside, actually inside of the building. I didn't do this. I don't know why, probably I forgot it, but would be interesting to see if we can connect outside of the buildings with interior. But nevertheless, as you can see right now, I have a fully different perspective with my phone and those images will still be matched in the same model. This was also my purpose to show you how to do it. Okay, uh, here I actually overrate a bit, not sure those images are also successfully matched, but let's see this later. Okay, hopefully you have now a good idea how I did it. So the first and main important point is that you try to get similar perspectives with a drone and with phone. At least let's say 5 images which needs to be from the same distance from the objects, from pretty the same height and same scale, and then you're able to successfully match all the images in your bundle adjustment step. Of course, if you will fly with the drone on a 5 meters and you will trigger with the camera on a 2 meter height, this will also be okay. If you are not able to fly so close because of the trees or any object or something like that, this still will work. But if you trigger drone images from 30 meters and then add phone images from 1 meter, this is probably not going to be good enough. So please take care and doing it this way, which I already present you. Okay, those were my phone images. In this case, I actually triggered 81 images additionally with my phone. And what I need to do next step is I will create a new folder and name it like all images. I actually need to copy all images together. So let me just open another folder and make it like so. And I will copy all images which were triggered manually in this folder. Okay, then all images with my phone, copy. Okay, done. And of course the images which were triggered automatic with the help of a grid mission, also paste them here. Okay, this is now my folder, all images, all together 331 images, and I will just copy me the link from the folder, and now we can start with the processing in 3D Survey. I will run the 3D Survey software, start with a new project, and this is kind of a standard workflow. I browse for my images, just Ctrl A, open all the images. The telemetry importer window pops up. I will select here EXIF data, and I need to select my coordinate system. It's in Slovenia. I also have my local GeoID, which is Slovenia Copper 2016, and import all the images inside. Data was successfully imported. Okay, additional data here. As we can see, the RTK, we have high precision for all the images here, really nicely. 3 pixel images have also coordinates. The accuracy is, as we can see, 10, 10, 100, which is good enough. What I forgot to mention before, what's good to do before you trigger with your phone is that you turn off the GPS tagging for images before you start with triggering images. This is super important because the phone has a really bad telemetry data, not accurate enough in comparison to the drone, and then could happen that not all the images are going to try to be matched with all the others. So I didn't do for first three probably, those are kind of critical, but then I just remember, okay, I need to turn GPS off before I start triggering my camera. And in this way, we will try to match all the phone images with a complete model. It will take a bit longer, but nevertheless, there's a much better chance to include also those images in the model. So once again, before you start triggering phone images on a field, turn off the GPS of your phone, that all the imported images will be also then successfully matched. Okay, cool. Let's go to image again really quickly. If I'm moving down, those are my images from drone. Still Nadir images. Here we can see different name. Those are images which were manually triggered. And here we have another camera, Google Pixel 5. Let's see. And those are my images from the phone. Okay. If we see the telemetry view, here we can see actually images from the drone. This one is probably from my Pixel or something like that, or was just badly taken also with the drone. And if I close the two, we can see here in the list of the image names that we have two cameras here. So the DJI camera and Google Pixel 5. We could have additional camera if we would like, but usually the phone is in your pocket. You can just take it off, trigger camera. Of course, if you have a good standard digital camera, it's always better than a phone camera because it has a bigger sensor, the pixels are bigger, and also the end results will be much nicer. Another option, instead of using phone or digital camera, it's also that you hold the drone in your hand and just trigger manually images. I will put the propellers before down just for double safety, but it's kind of a really good approach because in this case you have just a single camera which is super stable, which works nice, has a global shutter inside, and works really nicely. So if you don't have a phone with good camera, you can still hold the drone in the right hand, you trigger the images with left hand, you can use the gimbal to focus on a specific part, so works really nice. I already did few projects in this way. Okay, more or less everything is ready, nothing else to do than bundle adjustment. And my suggestion here is when you combine different cameras, always use hybrid model, which is kind of a global and incremental together and probably will deliver you the best end results of a bundle adjustment step. So select bundle adjustment and click OK. Okay, we start with the bundle adjustment. This will probably take half an hour or something like that for 300 images on my computer. We'll be back in short. Okay, and here we can already see the result of bundle adjustment. Totally 331 images, selected all of images and successfully registered 370 images. So we see few images were not successfully registered one. The easiest way to see this is probably to scroll in the image list, and those one who were not successfully registered, you can see in a silver color. So the black one are registered, this one was not registered. If I click here on image, I can see, not sure why this one was not registered, that one was. Not sure what was the reason. Also, this one was not successfully registered. Could be that I could need to set additional parameters. Maybe even too good texture was a problem. And those were probably because of the fully different perspective in comparison to other ones. And then again here, so approximately 14, actually 14 images were not registered, all from them from phone, but let's say 70 or 75 images from phone were successfully registered. So all those here. Let's go back to sparse point cloud view. We can see the complete model here also. Uh, a lot of cameras, a lot of blue triangles, because we are so close, the triangle is a bit bigger. But nevertheless, we see we successfully somehow combine drone images with phone images really nicely. What I'm super happy around is that we manage to overcome this step. So let me move again between the images. When I go actually here up, not yet, a bit further. So up here, I go actually inside in the first floor, and all those images are actually successfully matched. What is actually super hard for the algorithms, but we managed to do it in this way. Okay, so all those images are successfully also matched in the model. Okay, cool. Next thing is we need to orientate additionally this model because we have an RTK drone. Also phone images are super accurately orientated also based on RTK data, but we always suggest you at least to use, even if you have an RTK drone, at least one or better three ground control points to do the orientation just for the height control. So I have one GCP point in my case. Let me just browse to the GCP file. Okay, need to browse to the right folder. So field data, all images. The file should be somewhere here, GCP. It's point number 6. It's non-projection because it's a RTK drone, so all the coordinate system are fine. Let's go to next step. This is not a 3D survey target. I just measure one detail points, and I should see immediately the green circle of almost right position. It was actually this corner of two bricks, which I mark it on the field. I will just improve now this position by using the left mouse on number 6. I could also select it here from the list, and I will accurately show the software. So this is here, and let's do maybe on a second image the same way. So number 6 is here, and when I go to next step, everything should be already fine. That's all good. I need to deselect those images where the GCP is not visible, probably because it goes through the roof correctly. I have also multiple selection options. I select the first checkbox, then Shift plus left mouse in the middle of the image and deactivate, and so on. Let's continue for all other images. I have more than a lot of good connections here, nice images which are nicely centered in the GCP wizard. And when I go to next step, I should get the accuracy. It will be super accurate because we have RTK images with a 1 or 2 centimeter accuracy. We have one GCP points which will help us to improve the height of the model, that everything will be super accurately. We also have a GeoIT model in this case, And then based on all this data, also phone images with no telemetry will be combined addition, and the whole complete model will be accurately orientated. And the result is here. So super accurate because it's just a single point. This is fully logical. We just need to click on finish. And here we can see now orientated model also based on this one GCP point. This is so-called sparse point cloud. Even on a sparse point cloud, we can see where's our object of interest and so on. Okay, we are ready for third step. This one is a so-called reconstruction. I will do the reconstruction on a high level. This is, I think this will be more than enough, more than detailed enough. I will use my NVIDIA graphic cards to get a really detailed model. If you have options to use NVIDIA, definitely do that because the model is much nicer, much more accurate and detailed. Okay, if I click OK now, I will start with the processing. This will probably take 2 to 3 hours for those 300 images. Then we'll see the result of reconstruction step. And here we can already see our result of dense reconstruction. It's a point cloud. We have in total 52 million of points. You see pretty big area thanks to the standard grid mission and super detailed model for our object of interest. If I turn on off cameras and zoom in additionally, you can see almost every detail it's easily visible. And we also have a complete and perfect footprint of the building based on which we can easily use the CAD tools and connect actually our 3D polyline which defines the footprint of the building. The second important thing we need here, we need to draw out the roof dimensions. Instead of using measuring tape or traditional approach techniques, we can now easily do this also in a CAD tab, and of course then the lowest and highest point, it's easy to create it. But before we do that, we will just quickly select our area of interest, just like so. Couple of seconds to get the selected points in selection. And instead of delete selected, we will use delete other function, and we are going also to create a textured full 3D mesh for this smaller part. I'll click on mesh, calculate new full 3D mesh, point cloud, it's already selected the right one, we have just a single one. We would like to have texture, calculation level high, 2 million of triangles, and texture resolution full. So I would just leave it default settings and click on calculate, and then in a couple of minutes, or let's say in 1 hour, we have the also full 3D textured mesh. Okay, and the mesh is already here. Just wait a couple of seconds to get the texture on it. Okay, this is it. And this is our 3D model of a vineyard house, which will be renewed. And if we go to see what kind of detail we achieve, we can see that everything is really nicely visible. What was my goal in this project? To add also cameras from phone is to get also really nice detail here under the roof, and then of course also here inside to get this detail out of it that I can easily draw later on with the CAD tool tabs and CAD functions and create the footprint I actually needed. Let's try and draw now my main important things for this building. So I need a footprint. Let's go to the CAD tab. What I can do here, currently I see point cloud and mesh. which are available for this model right now. So because I'm comfortable with the mesh right now, I will just select my mesh and I'm going to draw based on mesh because it's super detailed. Let's go back to CAD tab. I will first create a new layer, host, make the layer active, set my red color, thickness to 3. Okay, use the draw line tool, and I'm going to snap actually on triangles and on endpoints. Okay, so first let's create a footprint, so like so. I think it goes like that way. Let's see. Okay, it ends like so. Let's go here to the corner of the building. So this is kind of basement. We are drawing actually on a based on a fully realistic model. Thanks to the side images, thanks to the phone images, the complete model it's covered super nicely and super accurately. Sorry. Okay, I'm going to get this corner of the building. Yes, let's take this one, and then I will click and I will snap to my endpoint. Okay, this is my footprint of the basement. I could connect also the first floor, but I think I give you a good idea. Now I'm going to create some 3D points. Actually, I need two of them because of the height. Display, okay, name and height. The first one will be here in front of the building. Oh, I need to make it my layer active. Let's correct quickly this. I will select the point, double mouse click on layer, 3D points, and that's it. And go back to the layer, to the point. I also need the highest point. This is probably here, like so. And of course we see the 3D height also here. And then in addition, I need to draw the roof the same way as I did actually for basement. Create new layer, set my color. I love thickness 3 because it's nice visible, and I will also use, let's say, mesh for the drawing the roof. Okay, I could create triangles that later on you can then easily also calculate the 3D area, that they exactly know how much material they actually need to get out of it. I just select, I just draw one triangle. If I select this one, you have also here the 2D area of this triangle, which is available. Okay, cool. This is it. Most of everything. So hopefully you get a really good idea how to combine those images. At the end, we show you also some addition CAD functions to get the real end results. And nevertheless, try it out by yourself. If you'll need some help in addition, feel free to contact us. Okay, so hopefully I try to explain you the most plastic how to do this, how to combine drone images just with phone camera. We are already at our last sections where we have audience questions and answers. I already copied me a few questions that we can start immediately answer them. Please feel free to write additional questions. I will read them and answer them. But let's start with those first three. So the first question is, do we always need ground control points for drone projects? My answer is depends what you are doing. So if you like to have your model really accurately positioned in a absolute coordinates, so that the model is really accurately on 3D coordinates in a worldwide system, so that some other data are being combined with this one, then it's great to use ground control points. If you need just a relative position of the model and you need just relative dimensions between them or angles or anything like that, for example, if you are planning to design solar panels on the roof, you actually don't need control points. The telemetry from a drone is more than good enough, especially if you use a RTK drone. So in this case, you don't need it. So my answer is depends on the project. If you have some additional questions, feel free to contact us additionally. Then second questions, what will be the difference in matter of GCP if I don't not use the RTK drone but the GCPs? Do I need GCPs on the phone pics? Okay, so I assume the question is what's the difference if I don't have RTK drones, actually the standard drone with the standard GPS. The only difference is in this case you would need to have more ground control points. Our suggestion is use 10 ground control points per project or per drone battery. So if you have a 500 by 500 meters, use 10 ground control points. In this way, you will always get super accurate results, even without the RTK drone. For such a small object like here, I would use 5 ground control points, or at least 4 on every corner, and it would be also accurate enough. There's no need that those ground control points are visible on phone images, because phone images are connected with tie points with drone images, and after we orientate the model and show the ground control points on drone images, the phone images are connected with the drone images immediately, even if you don't have no phone images with ground control points. So there's no need for it. The bundle adjustment step do automatically everything. And then third questions here is, you have sky visible in your photos, does this not matter? Okay, would be better if I wouldn't have it, but the sky visible just make us some artifacts at the end of the roof. Maybe I have here model on and I can show you the point cloud. Let's turn it back. Okay, so the effect of, okay, let's turn the mesh off. The effect of sky visible, it's maybe a bit more noise at the end of the roof or something like that, but we can filter out or clear out easily, so it's not that big problem. Okay. Okay, let's continue. We have few additional image questions. I will just copy them again in my question box. So I finish first three. Let me just copy them that you can also see additional questions. Okay, here we have more questions. And don't forget, there's still time to set your questions. Next question is about the circle flights. Do you recommend a certain camera orientation according to the flying height? Yes. So what's here important? Always point with the camera in your area of interest. So in my case, this was a building. When I go lower, I increase the camera angle up so that the model was directly in a circle of my image. So this is the most important thing. And try to build some kind of dome above the object. So when you fly it, you know, the highest circle will be probably more in the center of your object, and the camera will be more nadir. And then when you go beside, you need to increase the camera angle. When you go lower, you need to even increase more. So that the camera, it's the object of interest is always in the center of your image. What we are planning to do also, because you know we are also developing our mission planning app, so-called 3D Survey Pilot. We will actually design a mission calling DOM or something like that, where 3 circuits will be automatically generated. Hopefully this will be released in September and you can test it out and see how it works. So this is my advice to you. Next question, how did you obtain the exterior orientation of the phone imagery? Okay, I need to open here in a question box. The complete question was here, so sorry. Fighting up with my platform. Okay, I will continue to the next question, then returning one because I don't see the complete answer here. Can we create a project using only photos from the phone? Of course you can do it. Then just the orientation steps needs to be a bit different. Check out my previous webinar. Sorry, I will immediately go to my web page and check out the learn section, webinars, and check out I think it's this one, mapping building facades for 3D representation. See how I orientate the model then based on 3 known points where I measure the dimensions with the measuring tape, and this will help you with the orientation of the model. But of course, take your phone camera and just do the mapping with it, and that's it. Even what you can do, you can film a film and then some can get out the frames and calculate the model out of it. Don't forget, if you have a digital camera, use digital camera, which is much better in comparison to phone. Pixel number of the camera, it's not the most important thing. The sensor size, how big it is, it's important. Okay. Can we create a project using, okay, this was already the answer it. I need to create 3D model of apple trees for yield estimation. Are phone cameras gonna be a good match with drone images? Probably yes. Try it out. If it will be hard for you, send us your data set and we can have a look. Can you show the point cloud or DSM without the hand camera images? I run out of time actually, but there is a difference on some specific locations. So definitely where the drone didn't have images on, there's no point cloud. So actually the point cloud is a bit better, but good questions, definitely. Can we use some other camera instead of phone? Yes, use standard digital camera like Sony camera, Olympus camera, anything like that. It will be even better. Okay. Let me try to find also the question which was not answered. If you still have questions, please feel free to set it. Okay. The circle flies through. Okay, another question, is handheld P4 RTK the quickest and best workflow, or what is your experience? Okay, so for surveying purposes, Phantom 4 RTK is currently the best drone available on the market for mapping. It's not expensive. We use it on a daily basis, so I warmly suggest you to all you. So Phantom 4 RTK is the best one. The second one is Phantom 4 Pro. Super works with 3D survey software, so you get super accurate results. If you have big fields, so huge projects, the RTK version, it's definitely good decision because you need less ground control points for orientation and you get super accurate data. So yeah, definitely go and buy it. It's not expensive. You will probably do 3 or 5 projects and you earn your money back. When you're using network corrections for the were you using network corrections for the RTK drone? Yes, in Slovenia we have some kind of network of GPS stations, so you don't need a stick for the RTK drone. You put actually a SIM card into drone RC, which directly connects to the network and get the corrections. So this is through RTK, and in a second you get all the RTK coordinates. So it's really convenient. So we don't need actually to buy additionally stick for RTK and use it as a base and then do the post-processing for RTK coordinates. This is available in all countries who have a kind of a network of GPS stations. If you don't have this network, then you need to use the additional stick for the RTK. Will you update 3D survey pilot for circle, take photos? So 3D survey pilot already have a circle mission, but I was using here a DJI app. What are we doing now? We are now upgrading to a few different, few additional mission types. I think in September the new 3D survey pilot will be out, and it will be definitely very interesting. Let me just double check if there are some additional. Another question here. So the question is, do we need to give camera and lens dates into the software? No, there's no need for. We calculate them out, but if you actually calibrate your camera, you are able to import those calibration parameters in the software, and the starting point is better, the processing time is shorter, the end results are more accurate. But like for the Phantom 4 Pro, Phantom 4 RTK, Mavic drones, we already have a database of pre-calibrated parameters, so you don't need to do that. In my case, I could calibrate my phone camera and use those pre-calibrated parameters, would be even better, but I just go it straightforward. Sometimes it's easier. So yeah, it's possible, but it's just easier to select estimate automatically and the software do by itself. Another question connected with my previous one: how do I calibrate the phone? Okay, so the best way to do the calibration is to print out some let's say a map with few ground control points. Could be let's say you could put 5 targets on the building facades, measure them with a total station or something like that. This would be an area of 5 per 5 meters. Then you trigger about 50 images in a grid, vertical grid, of course manually, and you do the processing you do the bundle adjustment and orientation step. So let me go back to the software. So you actually import the images from the phone, you do the bundle adjustment, you do the orientation, and then after you finish with the orientation, you click here on a camera icon and you are able to export those camera parameters. I could export right now, but probably this one was not the best calibration project, but do as I already described you. So place 5 targets on the wall. Would be great that this wall is not going to be fully white or glass or anything like that. Would be great if there's an old building with as much as possible texture on it. Place 5 targets, so just stick them to the facade, measure them accurately with the total station and do the calculation, and then at the end save those parameters here. And next time, so these were saved in the folder, and next time when you import all the data, click here in the camera button and read out those parameters. Okay, and then those initial parameters will be actually taken as calibrated parameters. Okay, questions are coming and coming. Super fine. Let's see. Can you show the point we already explained? Do we need to give now? Instead of working with multiple camera. Okay, another question. How I can clean the points from point cloud that are closed to a wall, but they are in the air. Okay, cool. So let me open my point cloud. Let's show you a few tricks. So the viewer in 3D Survey works really fine. I will just deselect my CAD data to focus just on this one. So here we can see we have some noise on a building. It would be great to filter them out before going to calculate texture 3D mesh. So my suggestion is turn the model like so, and then just use the select tool like that. So this is the simple way. Right mouse to finish. A couple of seconds to get the selection result. And now I select a lot of points here. I also select some points here which I don't like to select. That's why we have deselect, and just quickly deselect all others. So then you can also increase the point render size to see a bit more what you actually select. Sorry. So you see those red points and click the delete button, and that's it. This is one option. The another one, let me do undo. The another one would be I use my bounding box and focus just on specific part. So let's rotate first the bounding box to the right perspective. A right mouse click on the corner of bounding box and moving together with the right mouse click. And in this way, I could just focus on my area of interest, sorry, where I try to clean it. So just help you with the bounding box to visualize what you would like to see. There is of course also tutorial available how to use bounding box. At the end you can turn off the bounding box to see those points even nicer, and in this way you can put just a single super tight plane and focus on it. But definitely this will cost you some time, but there are tools available in the software and should work normally. Okay, the same way you can go and clean all other points. Okay, back to questions. Yes. Can 3D survey works with 360 images? Let me think. I think there's no limitations, but the end accuracy is not going to be so good one. If you have some data sets, please share with us and we can have a look. We are not limited. Definitely you will need to have not the full panorama, you will need image per image from 360. Okay, so you will need the basic input inside, and yes, I'm pretty sure it can work. Also, check out my previous our previous webinar from my colleague. This one, step by step how to import the point cloud in AutoCAD, because the first example, I think it's a really interesting one. It's kind of a car system with 2 cameras on it, and the point cloud is awesome just based on 2 cameras. So check out also this one. Can 3D Survey Pilot work with P4RTK? Can we install 3D Survey? Yes, you can, because we have a SDK available, and you can have you find this SDK on our webpage. Not actually sure where it is. Let me try to find it. So start using today. Software. Okay, 3D Survey Pilot. And here is download Android APK. So if you download it and you install it on your drone, it's going to work. What's the cons of this one? It's not, it doesn't have an option to connect with the RTK with your base station. So when you are going to fly with a 3D Survey Pilot with the RTK drone, you will get just a standard accuracy out of it. But if you have a grid mission with RTK and circle mission with standard accuracy, the end result should be also fine. Check it out. Okay. Another questions, can we do a large area mapping with nadir images from drone as well as normal handheld full frame sensor camera, mainly for catastrophe measurements? Drone as well as normal handheld full frame. Yes, you can, but you need to connect those 2 models with some kind of side images. Okay, you cannot go grid mission and then immediately side images from the building. So this is not going to go together. You will need to have some circles or nadir images to connect this one, same as I explained it here. Okay. Maybe I didn't understand 100% your questions. So if you need additional explanations, please send me on support@3dsurvey.si question. Can we use some other camera instead of phone? Yes, you can use other camera, even better than phone camera. You can also use your drone and trigger, hold your drone in the hand and trigger manual images additionally, because a Phantom has a really good camera, as we already know. Put the propellers down before you're doing this, just to be on the safe side. Okay. Just going through the questions. Unfortunately, this platform doesn't have an option that I show you all the questions. Does digital camera need to have GPS? No, there's no need for. So if you have drone images with GPS and you have digital images without GPS, this will be matched together, and the camera images will overtake the positions from the drone images. But nevertheless, if you have just a digital camera, there are systems which allow you to mount on the camera with the accurate GPS. One of our partner, it's selling that kind of system. It's actually from South Africa, and feel free to watch this tutorial or webinar also, how to create an accurate 3D model using phone. So here you will be able to see how it works and what kind of system are they. They just actually have a special antenna which you connect with the phone, and actually it works really nice. Okay. Already answer. How you can clean points from the point cloud. Already answer. Okay. Okay, so right now, I think I run out of questions. Thank you for your patience. It took us a bit longer, but hopefully it was interesting webinar for you. Please, I will be more than happy if you put some comments on our support at 3D Survey email. If you were satisfied with this webinar, or what would you like to know in addition. We have some plan of the webinars in the future. Every second Thursday is a new live webinar actually. And of course, don't forget to go to our webpage, and under the Learn webinars, there is a great base for the already done webinars who are all, available on demand. Also, this one webinar will be placed here in 1 or 2 hours. So feel free, check it out, and that's it. Ignat Schilens, thank you. That was awesome. Great. Say hello to your family, to New Zealand, and see you in our next webinar. Thank you for listening and wish you a great day. Bye bye.